So, welcome back, everybody. Hopefully, you're having a good day. Hopefully, you're staying safe and healthy. Had a good weekend. Lots of things like that. So, we have a number of things to talk about. Actually, really only one thing to talk about today. We're going to be talking about databases. That was what the videos were on. I'm currently watching, one of the things that YouTube gives you is the number of concurrent viewers. And so I'm currently watching the number of people who are apparently watching this jump up and down very quickly. So either people came for databases and then got scared off by me talking, or who knows. So at any rate, what we're going to be doing today is just sort of introducing the idea of databases. This is what we talked about in the videos, in the lecture videos. On Wednesday, we'll really put this into action. What we're going to be doing on Wednesday is we're going to be taking that Music Rater app, and in the lecture and in the lecture videos, we'll talk about how we can structure that code so that it's honestly just better. The current structure is not particularly good. We're going to make sure that we have a better structure. And in making it a better structure that is less likely for errors, everything else, we'll also show how we can, once we have that done, make a couple of minimal changes to go from the approach that you can look at right now that's on the web page, everything else that is using CSV files, to a database. And then on Friday, we'll talk about how to actually secure our applications. But for today, I just want to introduce the idea of databases, how databases work, and in particular, how they're different than the files that we've been using so far. So far we had two ways that we've discussed for storing data. One is using text files, or I should say persistent data, that is data that lives beyond an application, just beyond one running of the program. One idea was text files, and text files are honestly very limited. We can read them line by line. That's about all we can do. So another thing that we've talked about a fair bit is, honestly, it's another text file. It's a little bit fancier in the sense that there are standards out there that tell us how to use it, and that's a CSV file. CSV file and a text file really don't differ all that much. They're both ways of storing data as strings, right? So I have a CSV file I found online. This is apparently real data. And what it is it is the top 50 most streamed songs of the last several years, according to this person. I have no idea where they came up with it. It is 50 songs. And for each song, you can see there's a CSV file, right? Separated by commas. It separates the data into fields. So each row here has 4 fields. The first thing is the title of a song. So this first song is Señorita. The second thing is the artist who sang it. So this is by Shawn Mendes. The third field is the number of beats per minute for that song. So all of us who want to get our inner DJs on and start getting the party started, and I don't do this sort of I keep joking I don't do this sort of thing, or say this don't do this sort of thing. I was actually a program manager when I was in college of my college's radio station. I actually do this sort of thing. I just don't do it with music that's been made recently because I'm old. But anyway, so we have the number of beats per minute. But note that beats per minute here is stored in human readable form. In fact, there isn't much of a difference between numbers and strings, and that's because CSV doesn't differentiate. Everything in a CSV file is simply a string. And then the last number here is the length of the song in seconds. So you can see different songs have different lengths of time. Now, there is actually more to the CSV file standard than just simply saying commas. We use commas to split them between the different columns of data. And in particular, those different standards are there for dealing with things like, what if our data has a comma in it? What if our data has quotation marks in it? Things like that. But that doesn't matter. To be perfectly honest, that's why we use the CSV library. There's still some students who don't use that. It's really silly. It's going to make your life difficult. Use the CSV library. But given all that, now what we want to do is start to talk about databases. So databases are going to be very different than CSV files. I'm going to turn this CSV file into a database. I'm going to create a database for it just to show these differences and show the basics of database programming. One of the biggest differences between a database and a CSV file is we are going to need a file to store our database. Typically, these have a .db ending, the same way that CSV files typically have .csv and text files have .txt. The ending doesn't really matter. The computer doesn't know any different. It's just a way of making it easier for us to understand and to sort of give hints, at least if you're in Windows, primarily Windows, to the operating system for how to open it, how to manage that file. But beyond all that, the biggest difference between a database and a file is in the contents of it. A database is going to be not human readable by and large. And even where it might be able to be human readable, it's not really designed to be read by humans. It's designed to be read, processed, added to, removed from, updated, everything by the computer. So it is a lot faster for most data uses, but of course debugging it is going to be a lot harder because we can't read the file. So the way that we start using a database, just to get into this, is for this class, for 115, we're going to be using the SQLite 3 library. There are lots of different databases out there. SQLite 3 is relatively simple. You'll note that it has the word light in its name. That's not unintentional. And as a result, it can be very, very fast. You don't want to use this for huge data sets. You wouldn't want to use this for something where you're doing lots of really in-depth data analytics, but that's not what we're doing in 115. For small applications, for simple applications, not even that simple, SQLite is plenty sufficient and actually really, really quick. So it's going to be very good that way. So the first thing we have to do for a database, right? When we wanted to use a file, we had to use that with as, with open, whatever, as. For a database, what we're going to have to do is connect to it. And the way that we do that is we have this call sql3.connect, and then we pass in the file name as its argument. Now that argument can be a string literal if we want to do that, or like in this function, it can be a variable, whichever one you want, as long as the variable evaluates to a string also. Now, when we connect, call that connect function, it's going to return a database connection. It's not the most beautiful language, but it's true. And we're going to need to use that connection. So here I have this function to connect to the database. It's going to return the connection. That's fairly common. You can actually see the code down here. And they're pretty much three functions that we use with that SQL connection, with that database connection. The first one is cursor, and we're going to end up using that cursor to do almost all of the work. So in order to get the cursor, we take our connection variable. Here I called it con, seems a good name, and we call dot cursor, and that's going to return our cursor that we can use. And this is what, like I said, we're going to use this to create tables, to add to tables, to update data in tables, to retrieve information from tables, to delete things, all the sort of work we want to do. There are two other calls that we use a connection for. The last one, this con.close, this is what we do when we're totally done with the database. At the end of our program, honestly, it's not actually required to call .close. It's good practice. It lets the computer clean up a little bit, but it's not necessary. A bigger one is this .commit. And to explain this .commit, it helps to understand how computers sort of operate. So in our program so far, we've been using all these variables and everything else more or less interchangeably. the fact is there's a big difference between our variables, the memory that we use, when we're using variables in our program and calling functions and all that sort of stuff. That usually largely takes place in RAM. When we use files, that takes place those are stored on your hard drive. And there's a huge, huge difference in terms of speed between all of that. In fact, it actually goes more in depth than that. There's a limited amount of memory that the processor, that your CPU can use instantaneously. Those are called registers, a register file. And that has, you may have like 64, maybe even 128 registers. So you can have 128 pieces of information that it can access directly. And that's pretty good. There's other bits of memory that are in the processor. These are called caches. They're actually in different levels, L1, L2, L3, sometimes even L0 and L4. And what happens is as you get to higher numbers, so from L1 to L2, L2 to L3, L3 to L4, you get more and more memory. Your L3 caches can be a couple of megabytes large now, but they get to be slower. And it's still going to be pretty quick. We're talking 100 cycles, not even 100 cycles probably. For your L3, you're talking about 50 or 60 cycles. Depends on the processor, depends on the system, depends on exactly how it's set up. But, from our perspective, that's instantaneous, right? Each cycle, if you're on a gigahertz machine, there are billions of cycles a second. So those cycles are instantaneous. But from a processor's perspective, it's sitting around waiting 50 time units just to get the information. So it's fairly slow. All this is nothing compared to when it has to go out to RAM, when it actually has to go to your memory. When it has to go to your RAM, right? Now you have a lot of this. I think in my computer right now, I can show you. So I'm trying to see where it has used to be system report. So you can see I'm on a Mac right now. So on my computer, if I look somewhere in here, they're going to have, of course I can't find it. Yeah, you can find the you can see here I've got L2, 256 kilobytes, not much. L3, there's 6 megabytes for the whole processor, a little bit more. In terms of RAM, I have 16 gigabytes. So a fair bit of memory, but not nearly the speed of my processor. It's going to probably take a good 100 cycles or so in order to be able to get anything from RAM to my processor. So that's really, really slow. But what's even worse is if I want to use my disk. So if I look at storage here, you can see on my computer right now, my hard drive has a half a terabyte hard drive. So in that sense, it's pretty good. But in terms of speed, it is incredibly slow from the computer's perspective. From the processor's perspective, we're going to be talking hundreds upon hundreds of cycles to get information from the hard drive, or if I try to store something on the hard drive. Now imagine you're writing a database, right? You really are optimized on speed and getting data really fast. The last thing you want to do is touch the hard drive. That's going to be really slow. Touch your disk drive, touch a file. So what the computers do instead is they try to minimize how often stuff gets saved back to disk. And so every time we do an update, it may not save it back to disk. In order to actually have it saved back to disk, that's why we need to use this commit function. Really long-winded way of talking about this commit. Basically, you can make any changes you want to your database. Until you call commit, it may not get saved to the file. And that's for speed. So we tend to, if you're writing a real serious application, again, nothing you'll be writing, honestly, for many of you, probably until you graduate, will these differences in speed actually matter. But at some point, you will get to a point where you do start to have to play around a little bit with where you place the commit calls. For this class, if you want to think about it, every time you're done writing data to the disk, making any sort of changes, that's when you call commit. So we can start this up. I'll connect to my database, get the cursor, do a commit, which actually doesn't do anything. I haven't done anything yet, and close it. And you can see when I run this program, nothing happens. I did connect to the database, but I didn't do anything on it. There's no reason to create the file. In order to be able to use a database, what we need are tables. And a database can contain one table. It can contain many tables. It's a matter of what you're trying to do. The way that we create a table, we're going to need our cursor. So I have a function here with a cursor. And we're going to have to use that cursor's execute function. This is the function that does pretty much everything with our database. And when we call execute, we give it typically a single argument. Talk about it a little bit more later on. And for an SQLite database, the SQL, that's a language that we're going to use. It stands for Structured Query Language. Don't worry about it. Don't even worry about the details of SQL. You'll learn that later on when it's more important. For now, just understand that there's these series of commands, and you should be aware of what the commands do. So if we give you a command, you can understand what it does. That's primarily what we're going to be looking for. Maybe understand what the commands are. Don't worry about the details of them. The first one we need to learn is how to create a table. Like I said, all data in a database is going to be in one or multiple tables. The way that we create a table is we send this SQL command, create table. And typically when we do that, we're going to say create table if not exists. And what this will do is this will go into the file, see if that table exists. And if it does, bonus, doesn't have to do anything. If the table doesn't exist, it will then create it for the first time. So this way we don't overwrite anything. We don't get any errors. The next thing we need to have is the name of the table. I named this one Pandora since it's dealing with music in the top 50, and that seemed like a good name. And you'll see I have this broken up into 2 lines. I have it broken up into 2 lines so all of you can see it. Normally this could be on 1 line. After the name of our table, we have a space, and then inside of parentheses, we specify the names of our columns. And the names and the order are really important. We're always going to be following the same order. The database is just going to follow it blindly. So for each piece of music, I'm going to say we have the name of the song, the artist who made it, the number of beats per minute, and the length. So right now I'm going to run this code again. No, I'm going to connect to my database, get the cursor, create the table. I'm not going to do anything else except for committing and closing it. So if I run this now, then it should. And of course it's not because I'm looking for it to do that. Let's see what happens if I can do this. So for some reason it's decided not to create the file because I'm trying to do a demo, of course. Let's try doing this. Let's just try reloading the page. See if that helps. It'd be really nice if there we go. Reloading the page took care of it. So you can see our CSV file, it's still the same. But now let's look at the database file. The CSV file was nice and readable. This database file, and remember, all we've done is created the table. We haven't actually added any data to it yet, is virtually unreadable. Oh, there's something. You can sort of see something table, Pandora. There's Pandora again, create table, Pandora, name. There's some weird stuff here. But most of it are these weird sort of question mark characters. If you wanted, you could go in. What it is, it's not that these characters are actually always the same thing or anything else. What it is this file is largely written in binary, zeros and ones, that the computer understands. That's how the computer's optimizing it. The downside of this is it makes it very, very difficult for any of us human beings to understand it. In fact, when Replic's code is trying to translate those zeros and ones, those bytes of information into something that I can read, ASCII, it can't. The only place where it can sort of do that is when the zeros and ones happen to be storing strings, because then they're displayed as strings. That's actually the way that they're stored. But for most of this, it's not human readable. So this is going to be one big issue when you use a database. You can use it and they're very powerful, they're very wonderful, but you're not going to be able to actually read those data that come out. So we've now created our table. Probably want to do something with it. So let's think about the music, the data that we're going to add to our table. So we want to import the music. It's currently in this top50.csv file. So I have this function import music to take care of this. So I'm going to say with open, right? To open a CSV file, we have to use that with as and create our CSV reader. Not how we deal with the database. Database, we need a connection. Our CSV file, we use a CSV reader. And then what we can do is say for row in reader. And just to sort of, think about this, I'm actually going to not do all that work yet. What I want to do is I'm going to cheat. And I'm going to use this function type. Type is a function, it's built into Python. And what it does is it returns the type of a value. So as we go through the reader, I just want to print out what type each row is. So what is our CSV reader providing us for each row? And then, because I can look at the file, I happen to know this, right? It's got 4 columns. So let's look at the type of data in row 0, that is the artist, or that's the song, the song name. And in column 2, if you remember, is 0, 1. It's the number of beats per minute. And now this would dump out a lot of data. So what I'm actually going to do is I'm going to return it immediately afterward. I'm not going to. Okay. That was interesting. What I'm going to do is just return immediately afterward so we can see the output. Not loop through everything. And so I'm getting an error. I'm getting an error. I've actually corrected this for probably some of you. I put in type. Type is a function. Remember, functions get parentheses, not brackets. I screwed that up. Mistakes happen to all of us. When it happens to you, don't feel bad. No, it happened to me. Okay, so here we can see that what are we getting when we use a CSV reader? We're getting a list, right? That's the type of row is a list. And at index 0, for the name of the song, we're getting a string, a stir. That makes sense. But note, for that beats per minute, we know it's a number. We know it's a number because we can read it and we have an IQ of 0. The computer says, nope, that's a string also. So whenever we want to do anything with data, right, whenever we're using a CSV file, we have to always do a typecast, right? We have to typecast it to an int. One of the things that a database is going to allow us to do is not have to do that. So what I'm going to do right now is I actually broke this into 2 steps. I'm just going to get the name, the artist, the beats per minute, and the length. I store them as variables just because it makes the code easier to read, hopefully for all of you. And what I'm going to do is I'm going to create my SQL string. I could just do this all in the call to execute. I'm creating a separate string, honestly, because I want to print it out. And again, I'm just going to do one command so we can all see how this works. To add data to a table, we need to use an insert command. So the command is insert into. And then we have the name of the table we want to add something to. And I had named the table Pandora. And then we need another keyword, values, saying here are the values I want to insert. Then we have, again, an open parenthesis. And in the parentheses for the actual unsafe version, And we'll talk a little bit on Wednesday and a lot more on Friday why you don't ever use the unsafe version. In fact, it took me a while to remember how to do this because I never ever actually use this in real life. But as a first step, I want to show this to you. What you have to do is provide the values that you want. Now, all of our values, are strings right now. So what I said is let's have a name, right? Let's get in the name and then a comma and the artist and a comma. And note the commas have to be in strings because we're making a single string. And then I want beats per minute and length to be numbers. So I converted them to ints, did a typecast for ints to create my SQL statement. So let's say, for those of you who watched the video, I think it was on Friday, and saw my daughter just texted me. Sorry about that. My daughter's still trying to take over the class, apparently. So what do you guys think? Is this code going to work? When I run this, am I going to be able to insert the Shawn Mendes song into our database? Yes, no, answer in the chat if you want. I don't see any answers coming in. That's okay. Not necessarily the most obvious thing. So right, we got a computer. Easy way to find out. Let's run it. Funny thing is, this one, even if you knew nothing about databases, if you just think about Python, you'd actually be able to come up with the answer. And the answer is, this isn't going to work. One thing, if you haven't learned yet, you can actually use these tracebacks, the errors that Python gives us, to see where an error is. What it does is it shows you how the program got to where it is. So it's saying, I was first on line 41. I called import music. That took me into import music. And then on line 32, I have an error because you are giving me beats per minute as a string. Well, it's a string, but then you're converting it to an int, right? And we're trying to concatenate, we're trying to combine a string and an int. And that's not legal in Python. So we have to keep those as numbers. So it's relatively easy to do. Get rid of this, right? They already were strings, so I can keep them as strings, make the concatenation happier. So now I can try to run this and see what happens. And we can see two things. The first thing that we can see is, look, that actually went through. I have this nice SQL command, insert into Pandora, values, and then we have the artist, the name of the song, Señorita, the artist, Shawn Mendes, and my two ints. But it still didn't work. On line 34, we're getting this error, near Mendes syntax error. The problem here is very much like when we are working in JSON. Remember that if you want to do your own JSON encoding, anything that isn't in quotes is assumed to be either a number or a Boolean. SQL and SQLite does the exact same thing. So here with Señorita and Shawn Mendes, it's assuming they're numbers, and they don't really work as numbers. So what we need to do is we need to use quotation marks around them to say this is really a string. Now the problem is we need the double quotes, which don't really work because, of course, that is a quotation mark in Python, and it's going to be a fight. So what I'm going to do is I'm going to cheat, and I'm actually going to use the single quotation marks for my Python string, and that allows me to use the double quotation mark that SQL wants inside of the SQL. So I can do that again. And now we need for artist to be in quotes, but for BPM and length, I can keep them the way they were. I don't want them to be inside of quotes. So now if I run this, it worked. So we were able to add something into our SQL database. At least, I mean, I think we did. We didn't get an error. So we can check out the database to see what happened. No, actually, we can't remember. Again, when we're using a database, have we added data? Probably. Can you tell? You know, I think we did, because if you look at the very bottom here, it has Senorita and Shawn Mendes and some other characters around or whatever. But remember, we're never going to be able to read the database. That's not something that can happen. So we just have to assume, since it executed perfectly well, that we're okay. So this time what I'm going to do, I'm going to get rid of this print statement. I don't need to see all the inserts. Hopefully you're all comfortable with that. And what we can do is rerun this. I'm actually going to delete the database and have it recreate itself. No, I'll just do it this way. I'm debating going back and forth. No, I'll delete it. Now if we run it, it all worked. Presumably, program ran, yay. So what do we do? Let me go try to read in the data that we added to our database. Call this read music table. So the way that we can read from a table, we're going to again need the cursor. We're going to call it execute. And now what we're going to do to read in data from a database, we have to use a select command. So I'm going to call cur.execute, and I'm going to use select star. This means choose everything from, another keyword, and then the name of the table I want to use, Pandora. And just to show you what we're going to get back, what I'm going to do is going to give us a response. I'm going to print out the type of that response. And when we do that, what we're going to see is it works, but note what printed out. Note what the type of the response is. When we call cur.execute, we get this weird thing back that is itself a cursor. We don't get back a list of data. We don't get back a tuple of data or anything else. We get a cursor. Now, we actually want the data. We can't use response as a list. We can't use indexes with it. We can't talk about response at index 5 or anything else. There's only one thing that we can do with that response, and that is use it in a for loop. So we can say, just like we did with a CSV reader, for row in, whatever our thing is. So we can use that as a collection. So for row in response. And if we do that, I'm going to show the first row of our data. Real quick, we can run this. And you can see that each row is going to be not a list, but a tuple. Tuples and lists, if you remember, are very closely related. The difference is a list is mutable. We can change the contents of a list. A tuple is immutable. We cannot change its contents. If we want to change its contents, we're going to end up making a whole nother copy, a whole nother new tuple to do that. But otherwise, they're fairly similar. We access them the same way using indexes and everything else. And you can see that the tuple itself is got 4 different pieces of data, 4 columns, and they match the way that we added the data. So the first thing is the name, Senorita. Second one is the artist, Shawn Mendes. Then we have the beats per minute, 117. And note, the database is storing this as an int. I don't have to do any typecast. It remembers that it's a number. This is, again, part of the strength of the database, though part of the reason why we can't read it when we look at the file. And then finally, its length, 191, which is itself an int. So I don't need to print this information out anymore. I'm going to get rid of that. I certainly don't need to return. If I want, there are 2 things I could do with this as now. There you go. One thing I could do is just append each row into my accumulator. This is typically how we create a list of data from a database. We're going to create an accumulator, declare an accumulator, set it equal to an empty list. call our select statement, go through each row, each record that's in the results of that SQL statement, and add it to our accumulator. And this works perfectly well, but of course what this means is our accumulator will be filled with tuples rather than the actual lists that we might want. For anything that we're doing in this class, it probably doesn't matter until we get to tomorrow or Wednesday when we need to send this data over JSON. JSON has support for lists. It doesn't for tuples. If we wanted to add a list, so we have a list of lists, we can do that. What we're going to do is rather than appending the row, we'll just make a new list and say it has the same columns. I can just take the columns. And note there's nothing much like with and my list. Much like with the CSV files and everything, I still have to have an idea of where my columns are, how they work. But if we do that, then what we can do is I can add this here at the back end. We can print out this list that returns and actually see how many things are there. And what you can see is that we have 150 records in our database, despite the fact, see all these lists, despite the fact that this CSV file only has 50 lines. The reason we have 150 things is I've run this program now 3 times. And every time I ran the program, I had this call to import music. Remember that a computer has an IQ of 0. And this data gets saved from run to run. It is persistent. Every time we say add, Call You Mine by the Chainsmokers, which is actually really slow, 104 beats per minute, though longer song, we're going to end up adding that record, even if that record's already in the database. It'll just add another copy. So you can see all sorts of, there's all sorts of different music in here. We can do all sorts of things with it. One last thing that we can do, and one place where databases are really useful, is like I said, they're really optimized for the computer. So it means we don't have to store, we don't have to do these typecasts over and over again. That makes life a little bit easier. Not a big deal. But where it's really, really powerful is when we can do searches. So again, there are 2 different forms of searches. There's safe searches and unsafe. I'm going to do the unsafe today. I'll show you why it's unsafe a little bit at the end of class on Wednesday, and we'll talk about a lot on Friday. But what I can do is when I do a select statement, I can add a where clause. And a where is a way of saying, I don't want to select everything. I only want to select some things. So for instance, we can say where name equals, I probably should come up with a better name than this, but oh well. The first name I saw is fuck, I'm lonely. This isn't going to work because I need that quote in there. We'll do it this way. We'll do the number of beats per minute. So beats per minute is called BPM, where BPM equals, I could do a search for strings, but this one has a quote in it and it's just a pain. So we can say, let's look for everything that has 95 beats per minute and return and print that. And return and print that after I close the quote. And so you can see there are 2 songs, it seems like, that have 95 beats per minute. There is Fuck, I'm Lonely from the 13 Reasons Why Season 3 soundtrack. And Cross Me by Ed Sheeran. Wow, that is an interesting combination. I would never have put fucking and Ed Sheeran together. Well, now that I've made sure that this is firmly for adults, you can see there are 3 columns of or 3 copies of each of those, because I've run this 3 times. I've added it 3 times. The computer doesn't have a problem. But note, I was very easily able to just find those values. Suppose that we want to get rid of Ed Sheeran, because that seems kind of silly to me. What we can do is we could do any sort of Boolean logic out there, any of these ands or ors. So we can say not only the beats per minute in that row has to be equal to 95, but we'll say that the length is less than 200. We can use greater than, less than, greater than equal to, less than equal to, whatever we want. And now if we run this, you can see we just get that one song, because I tailored it to just get that one song. So we can, though there are 3 copies, we can make this work however we want. We can change the number of beats per minute. We can look to see how we can mix music together, all sorts of different things by combining different types of queries. So does all that make sense? I realize there's a little bit of a whirlwind, but I just want to give you a feel for how we use these databases, the create command, create table if not exists, the insert into, and the select command. That's largely what we're going to be doing. Our lines 38, line 38 is just the import statement. That's just calling this function. It's only connecting to the database once, right? The connection to the database, good question, is when we make this SQLite.connect. So that's what's going to do the connection. In order to get that in my code, it's on line 35, right? We need that connection to get the cursor. It isn't connected twice. It's only connected once. We make that one connection. We do pass it as a return value, assign it to a variable, same connection. We then get the cursor in here. And with that cursor, we can then create the table. That just makes sure, and because we do create a table if not exists, that's safe. The reason why you're seeing music 3 times is because I kept calling import music. As I was testing this out, I was importing another copy. So for instance, if I run the program now, right, before we had 3 copies of Fuck I'm Lonely. I really should have thought of this before I started doing this example, so I can now say fuck as many times as possible. You're all in college. You've heard those words before. It's the name of a song. It's not my fault. Please, Dean, if you're listening to me, it's the name of the song. I swear I was not doing this to say fuck as often as possible. Side benefit. If I run this now, because I'm going to import the music another time, we're not going to have 3 copies of each song. We have 4. We're only connecting once. We're only executing that select query once. It just happens that we've inserted all of those top 50 songs 4 times. So there's 4 copies of each song in our database. Does that answer your question? Does that make sense? It's not that we're connecting multiple times. It's just that there's a lot of data in our database because I keep running the insert statement, the import music call. Good. That's a good question, and I can totally see where you're coming up from that. No, remember, computer has an IQ of 0. We actually could make a second connection. I don't know that we ever would want to. I don't know why you would want to, but you can. No, honestly, we never do. We only make one connection per application to the database. There's no reason to. All that we do with the connection is get a cursor, call commit, call close. We could do, we do sometimes use multiple cursors if you're trying to do multiple queries at the same time, but that's less common. But excellent question. Any other questions you guys have for me? Any other questions about how this basics of databases? Like I said, we're going to spend the rest of the week on this. We're going to talk more about how we can use a database in a real application on Wednesday and how we can secure our database applications on Friday. It turns out that a huge number of database applications on the web have these well-known security holes, and we'll talk about why at my previous job I was never allowed to use any of their applications. I was not allowed to use any of the online applications. It said so in my record. That's actually true. We'll talk about that on Friday, how to break them, but also how to protect your own code. So, any other questions? Okay, I don't see any questions coming in. So, what I'm going to do then is say goodbye to all of you. Thank you all for paying attention to this. Hopefully this was helpful. If you do have more questions, obviously Piazza is available. I'll have office hours on Wednesday. The TAs have office hours all this week. Please make sure you stay safe. Make sure you stay healthy. And as always, make sure you try to have a little bit of fun every day. Okay, thank you all. Goodbye. Talk to you on Wednesday.